If you haven't already, take a moment to attempt to solve each of these warm-up questions and pause the video. Unpause the video when you are done. Here we go. So in number 1, we've got the square root of 108. And our goal is to try to simplify this as much as possible. One way to simplify a square root is to try to find perfect squares that are factors of 108. Because if we can find a perfect square inside there, we can actually take the square root of a perfect square. Perfect squares would be things like 4, 9, 16, 25, 36, 49, etc. So if you go through that list and you keep dividing them into 108, the biggest one that you can find that goes into 108 is 36. So we can rewrite the square root of 108 as the square root of 36 times the square root of 3. The reason we pick perfect squares to factor out of 108 is because we actually know the square root of a perfect square. The square root of 36 is 6. This means the square root of 108 can be simplified to 6 times the square root of 3. Now, in number 2, there's a couple different approaches we can take. And one of those approaches is recognizing the product rule of radicals, which allows us to multiply the radicands, that is, those things underneath the square root symbols, when the indexes match, which they do here. So I could rewrite this as the square root of 6 times 24. 6 times 24 is 144. And then the square root of 144 is 12. On number 3, we see an example of the quotient rule of radicals, which says that if we have the same indexes, which we do, these are both old-fashioned square root symbols, we can combine the thing in the numerator and the denominator together. We can write this as the square root of 42 over 3 with a negative sign out front. And then we can go ahead and divide 42 by 3, which gives us 14. So the final answer is the square root, negative the square root of 14. Find the zeros of each function. When we're asking to find the zeros, we're trying to figure out what values of x would make the entire function 0. Recall that those same values of x that make the whole function 0 are also the x-intercepts. So let's go ahead and try to figure out what values of x solve this. One method you've learned so far is that you can factor this polynomial in order to figure out the x-intercepts, or the zeros. So I'm going to write this in factored form by first writing each of the binomials times each other. Then, since this is what's called an easy trinomial, meaning there's a 1 in front of the x squared term, we can use a method that allows us to write down the solution very directly if we can find two numbers that multiply to a positive 16 but add to the middle term negative 8. Well, the only way we're going to get two numbers to multiply to a positive number but add to a negative is if both of the numbers are actually negative. So that means our signs are both going to be negative. Now let's list the factors of 16. And let's keep in mind that they have to be negative because otherwise they're not going to add to negative 8. So we could have negative 1 times negative 16, which adds to negative 17. So that won't foil into the correct factorization. Say negative 2 and negative 8. That adds to negative 10. So those two factors are not correct. And we could do negative 4 times negative 4, and bingo. They add to negative 8, which means this is factored as, that will be factored as x minus 4 times x minus 4. Great, it's factored, but we're not quite done. The question is asking us to find the zeros, which means we need to find the actual x values that make this function 0. Well, there's a rule called the zero product rule that says that if we can figure out what makes one factor 0, it's going to be a solution. So if I want to know what value of x makes this second factor 0, the only thing that would work would be when x is 4. Because if I put 4 in for x and I subtract 4, I get a 0. 0 times anything is 0, which means both sides of the equation is 0, and it's a solution. Now over here, the solution is still just 4, since these factors are identical. So there's really only one answer, x equals 4. Now let's take a look at this. If we're trying to find the zeros again, same steps. Set it equal to 0, set it up to be factored, and find factors that multiply to negative 24 that add to a positive 5. So let's go ahead and start listing things that multiply to negative 24. Things like negative 1 times positive 24, negative 2 times positive 12, negative 3 times negative 8, positive 8. I'm going to stop here because we're looking for factors that multiply to negative 24 that add to a positive 5, and we've just found them right here. This means it can be factored as x minus 3 times the quantity x plus 8. Now that it's factored, we can go ahead and directly figure out what makes this thing 0. So if I look at the second term, the value when x is negative 8 will give us a 0, and the value when x is 3 will give us another 0. So those are the two solutions, x equals 3 and negative 8.